Problem number 16. So P is the point 1, negative 2, 3. Q is the point negative 1 to 11. R is the point 0, 0, 4. And so we're going to have, here is P, here is Q. We have vector V goes from P to Q. Here is point R, vector W goes from P to R. So the first thing here is we need to find the cosine of the angle theta at vertex P of the triangle versus P, Q, and R. So this is going to be cosine of theta is V dot W over magnitude of V times magnitude of W. So what are V and W? V goes from P to Q. V will be negative 2 comma negative 4 comma 8. Negative 2 comma 4 comma 8. And W going from P to R is negative 1, 2, and 1. So their dot product here, V dot W, is going to be negative 2 times negative 1 is 2, plus 4 times 2 is 8, plus 8 times 8 is 1. And that looks like 18 to me. We also need the respective lengths here. The length of W is the square root of 6. The length of V is the square root of 64 plus 16 is 80, square root of 84. So cosine theta is equal to 18 over square root 6 times square root of 84. And so theta is equal to the inverse cosine of 18 over square root 6 times square root 84. I'm sure that simplifies down a bit. I'm going to omit simplifying that. This is a perfectly fine final answer. And then we have to find part B. We're looking for the projection of V onto W. That's what that's saying there. You know, as part of this decomposition, we need the projection of V on W. So that's going to be V dot W divided by W dot W times W. V dot W is 18. W dot W is 6 times W. 18 divided by 6 is 3. So the projection of V on W is minus 363. And so then to find, so this is V1 in the terminology of the problem. V2 in the terminology of the problem is going to equal V minus V1. So that's negative 248 minus negative 363. And if we crunch this out, crunch, 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 we should get 1, negative 2, and 5. And if you check for yourself that this, in fact, 1, negative 2, 5 is, in fact, perpendicular to negative 1, 2, 1. So everything checks out. So here's V1 and here's V2.